Hi, fourth graders. So I'm just going to give you a really quick recap of our review and then show you some strategies to make sure that you're comparing your fractions properly. So we have, for number 15, we have 3/4 is compared to 8/12. Now we want to find a common denominator with fourths and twelfths. We know that we can make fourths twelfths because we can multiply a number by 4 to get to 12. So that number that we're going to multiply is 3 to get from 4 to 12. So we must multiply the numerator by 3. So we should have 9/12. And then just to make sure that we're comparing it correctly, we're going to include 8/12 on the side and then compare. Okay. But that's not the only common denominator. And we get kind of another chance with number 16 with thirds and twelfths. We can take twelfths and break it down and simplify that fraction, 8/12, because I can divide 8 and 12 by the same number to get to fourths. So I'm going to leave my 2/3 alone this time. And I'm going to divide 8/12 by 4/4 because that gives me thirds, and 8 divided by 4 is 2. So we should get that 2/3 is equal to 2/3, or 2/3 is equal to 8/12. So make sure that you can do both multiplication and division to find common denominators. Now 17, we're comparing 0.7 to 0.75, and 0.75 is greater than, 0.75 is greater than 0.7, or if we read this left to right, it would be 0.7 is less than 0.75. On number 18, 0.4 is compared to 0.25, and 0.4 is greater than 0.25. And again, we start here in the largest place value and keep going and compare place values, but also compare the digits. On number 19, 8.04 comparing to 8.40. So this is $8.40, and this is $8.04. So $8.04 or $8.04. So our 4 dimes is going to be larger. And then finally on 20, we're comparing 50.07 and 5.70. And 50 is much larger than just 5. So it's going to read 50.07 is greater than 5.70. For 21, I'll read it to you and then we'll talk about it. A farm stand sells cartons of blueberries by weight. The stand weighs each carton to determine its price. The data shows the weight of the cartons of blueberries that the stand is selling. So this is our data, okay? And we're going to use this data to create a line plot. Now we know that a line plot starts kind of like this, and we don't need to make it any fancier than that. And we're measuring by quarter pounds. So we're going to label each mark on our line plot by quarter pounds, just so that we don't miss anything. And we can make this one. Okay, so we take each data point and how many goes with each data point. So we have 2 cartons that are 1/4 of a pound. So we'll put 2 X's. We have 3 that go with 1/2. We have 5 that go with 3/4. We have 3 that go with 1 pound. And we have 1 that go with 1 and 1/4. just 1. Now we need to make sure that we label the bottom of our line plot here. So we're going to call this weight. And we'll make sure that we put in pounds so that we don't forget what we're measuring our weight in. So general statements that you can make about the weights of blueberry cartons would be that most of the blueberry cartons, or the most common blueberry cartons, weigh 3/4 of a pound. Or the least common weight is 1 1/4 pound. Something like that, just to use the data and see what the data is telling us. Because the data always tells a story, so we have to figure out what exactly we need to learn from the data. For 22, we're using this shaded model here, okay? So the shaded part of the model represents the number of pennies Nate has in his jar. Write the number of pennies Nate has in his jar as a fraction and as a decimal. So I want you to do this a few ways. First, we're going to write it as an improper fraction. So in a whole dollar, there's 100 pennies. So that's going to be our denominator. This a little neater. That's our denominator. We have groups of 10, right? These are each a group of 10 pennies. So we can count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160. So we can write it like that, 160 over 100, or 160 100ths. We can also write it as a mixed number. So it's 1 and 60 100ths, right? Because we have one whole dollar here and then 60 parts of the next dollar, okay? We can also write it as 1 and 6/10 because there's, again, one whole dollar and then 6 groups of 10, okay? And then we decided that we can simplify this further, and you don't have to, but this 6/10 is not the simplest form. So if we divide both 6 and 10 by 2 halves, we get 3/5. Now, if we go back to this version and this version of our fraction, we can write it as a decimal number. So we always start with our whole, 1, and we write our decimal point because that's the placeholder for and. So it's 1 and either 60 or 1 and 6, right? So this is 1.60 or 1 and 60 hundredths, or 1.6 or 1 and 6/10. So that's the difference, but they all equal the same thing. For number 23, we have the question that says, a pad of paper has 100 sheets. Helena has full pads and 53 loose sheets of paper. What decimal number represents the number of sheets of paper Helena has? And I want you to cross this off, and it should be pads of paper, because sheets of paper doesn't make sense for what they're asking us to find. So first we want to start with our whole number. She has 4 full pads of paper. So we're going to write 4 because that's what we're starting with. Okay. Then we have 100 makes the total. So that would be our denominator. 100 is how many make up the next full pad of paper. She has 53 to make up the next full pad of paper. So it really is that she has 53 100ths of the next pad of paper. So we would put that as 53. So 4.53. And of course we want to include units, and that's pads of paper. Okay. And then 24. Vaughn bought 10 tomato seedlings. He has 7 seedlings that are cherry tomatoes, and the rest are plum tomatoes. What decimal number shows the fraction of tomatoes that are plum tomatoes? So we want to do a little bit of subtraction for this one, but we can also see, because we're using 10, that's a really friendly number. So I'm going to say, let's do some subtraction just to make sure that we're following all of our steps. So if there's 10 seedlings and we know 7 of them are cherry tomatoes and the rest are plum, that means that 3 of them are plum seedlings. It wants to know what the decimal number is of the tomatoes that are plum tomatoes. So if there's 10 total, 0.3 of them, or 3 of the 10, are plum tomatoes. And we would write our units as are plum tomatoes. Okay. And then you can even check your work by making sure that this equals 10 tenths. And that's how we would check our work. All right. Last one. 4 team members run in the 200-meter relay race. Kea ran 200 meters in 31.09 seconds. Both Sarah and Min ran 200 meters in 31.9 seconds. And Lana ran the race in 31.90 seconds. Did all of the team members run the race in the same amount of time? Explain. So what I would recommend is writing down all of your numbers next to each other. 31.09, or you could even, yeah, we'll do it this way. 31.9 and 31.90. And we'll give comparison circles so that we can compare these numbers. So again, we start with the biggest place value. So 31, all of these numbers have 31. Okay, then the next largest place value is the 10th place. So in this one, there's a 0 in the 10th place. In this one, there's a 9 in the 10th place. In this one, there's a 9 in the 10th place. So I can compare right away this number with this number because this one has a 0 in the 10th place and this one has a 9 in the 10th place. 31.9 is greater than 31.09. Now, 31.9 and 31.90 are the same amount because when I add a 0 after, to the to the right of those numbers, it doesn't change the value. But if I were to add a 1 here, now the number is different. But there's no 1 there, so I erase it. These two numbers are equivalent. So the question asks, did all of the team members run the race in the same amount of time? The answer is no. And you can explain that 31.09 is a different value than 31.9 and 31.90, which are equal, because this is 31 and 9/100, and this is 31 and 9/10, and so is this one. So just make sure that you're understanding your place value right after the decimal point. and then you'll be able to understand which is larger and which is smaller. Okay, let me know if you have any questions coming up before we continue on to the next unit. See you later.